Hello everyone. In today's session, we are just going to discuss about the feedback amplifier. Yes, there are four types of feedback topologies. So they are depending upon the type of sampling network and depending on the mixing network, we are having four categories. So our ultimate aim is to identify the nature of that feedback amplifier and to make the analysis of the given circuit, right? So here we have been given up with a circuit. Here the input is a voltage source. Rs is going to be the signal loss present in that voltage source, right? So this is a transistor, NPN transistor function in a common emitter configuration. So we are applying the input in between the base and emitter and extracting the output between collector and emitter. And we could see a RF, which is the feedback resistor connected in between the output and the input terminal, right? So this is the feedback resistor, right? We need to identify what is the type of network. So being an amplifier, obviously V naught is greater than VA. That is, since we are having a single stage, it's going to be of 180 degree. We are making use of common emitter amplifier, which produces a phase shift of 180 degree. Right. So here the current direction is being given. Okay. So if I want IF by applying Ohm's law, here the potential is VI and here the potential is V naught divided by RF. Right. So V naught by RF. Right. So this is nothing but your beta R naught. So in this case, if V naught becomes zero, the entire feedback current becomes zero. And that's why it comes under voltage sample. Next, we need to identify the type of mixing. We know the current will be divided only in a parallel circuit, and therefore it is a shunt mixing, and therefore the given topology is voltage shunt feedback, or else we should see mention it as shunt feedback. Yeah. First thing, we need to find out the input and the output circuit. Yeah. So what we have done here in the sense, so this RF actually it is connected in between the base terminal and the collector terminal. Okay. So whenever I want to find out the input circuit, I have to make the output parameter as zero. Here the output parameter is voltage. Therefore, this end will be grounded and the RF will be connected in between base and ground. And that's why we have connected it in the input set. Similarly, while considering the output circuit, we have to make the output input parameter as 0. Here the parameter is current, therefore take them the opponent parameter, that is voltage. So here the voltage will become equal to 0. So voltage is 0 in the sense it is being short circuited, that is this end will be grounded. Therefore the RF resistor will be connected in between collector and ground. So this forms the output circuit. So this is the overall input and output circuit. Yeah, right. We know IF by V naught is equal to the reverse transmission. That is the output of the feedback network divided by the input of the feedback network, fetch you the reverse transmission ratio, that is equal to minus 1 by RF. Right. So from this, I'm just finding out what is the resistance, that is RM resistance. Okay, that is closed loop resistance with the feedback V naught by IS. So what is V naught? Rm divided by 1 plus beta R. This is the generalized format. So in this case, what happens if I consider this beta Rm is greater than that of this one? This Rm and this Rm will get cancelled and RMF will be approximately equal to 1 by beta. Right? So RMF is equal to minus RF. Okay, that can be substituted over here. Next, we need to find out what is the voltage gain, right? So this is the formula V naught by Vs. Vs can be written as Is and Rs. We know this V naught by Is is nothing but beta. I'm just replacing it. 1 by beta is nothing but minus Rf. Okay. Then we need to find out the open loop trans conductance Rm. Okay. So actually this is trans resistance. Okay. V naught by Is, I can substitute in this way. Ic by Is can be written as Ic by Ib into Ib by Is. So this is nothing but our HFE. In order to find out this IB by IS, we have to apply the current divider rule at the input side. Okay, substituting, we'll be getting the open loop trans resistance. Okay, so we know D sensitivity is equal to 1 plus beta Rm. Substitute over here. Okay, you need not further simplify this expression, let it be. Okay, so the closed loop trans resistance is being calculated, and then what is the input resistance and what is the input resistance with the feedback, output resistance and output resistance with the feedback is calculated. Thank you.